Okay, so we'll now talk about firewalls and what a firewall is, and then routers. So a firewall is actually something we can attach to anything that's connecting to the internet to protect traffic going in and out of them. So we can attach them to routers, switches, and hubs. And then we'll talk about virtual private networks, which could impact firewalls. So a firewall is kind of a theoretical concept that can be implemented in hardware, it could be implemented in software, or a combination of hardware and software. And sometimes they're host-based, which is personal, like you could implement a firewall on your computer at home. And then also at a network level. So, so things that we could do with a firewall is have all data traffic from the outside separated from the inside for the firewall. We could allow only traffic coming in, for example, we could say only let traffic coming in from messages from port 80. So let's say we had, well, this is a little outdated, but let's say we had a web server and we only serve up pages on port 80. So only messages coming into us asking for port 80 would be allowed through. And we could allow all traffic except traffic that is on port 80. So that would block anyone trying to get to our server looking for web pages. If we decided we want to shut that off. So file transfer protocol, I don't know if you've ever done that to transfer files from your computer at home to the computer system here at the school. So instead of typing HTTP : at the top of your web browser, you could type, no, not your web browser, your file manager browser. You could type FTP and then your login and the school server, and you could log in. Now what you'd be doing is transferring files back and forth, but those files are unencrypted. FTP is unencrypted. And now Secure Shell is the encrypted version of it. So it's very popular to now shut off FTP. So we could use a firewall to do that. We could say no FTP traffic is allowed because it's not encrypted. On a network firewall, we use a firewall device, usually a computer running some software on it. We could implement them in hardware, but it's usually software because we're doing lookups on tables. And we install two interfaces. We connect our internal network as an interface, and then we connect the external interface. They both get connected into the firewall. And then traffic going between the two, we do lookups on tables. And so all data going to and from the internet travel through the firewall, following the rules that we decided when we set up our firewall. So, and then it's placed at the boundaries of trusted network. So if our internal network is a trusted one and the internet is a non-trusted one, we put it at the boundary of our network. So a host-based, what they call a host-based one or a personal one, if you have a computer and you're connecting even to a local switch, let's say these two people work for the same company, we could put a firewall in front of this PC where we're basically saying traffic that's going in and out through this line has to follow certain rules. We do lookups on tables to see if we're going to let traffic go through or not. And we could even have a secure switch and put another firewall here, and then this goes out to a router out to the internet. So this would be a host-based firewall for this PC, and this is a host-based firewall for this PC. So we could have rules what traffic is allowed in and out of this PC. And it's going to be based on the packets. We're going to read the packets to see what destinations, what IP addresses they're going to, and or what ports they're going to. And if we allow it, we allow it to go through, otherwise we stop it. Then we can put another layer here as we're trying to get out to the internet, like for, let's say, a company-wide rule that says we don't want traffic going through here. So we could put another one. So we could have layers of them too. And then, yeah, so sometimes it's popular to actually have layers of firewalls. So several firewalls can be used to prohibit traffic from passing through. And it makes it have different layers, especially a software, maybe a hardware, and then maybe a mixture of the two. It makes it harder for people trying to hack into your system to get through, because if they figure out how to get through one of your firewalls, they still have to get through another one, or several ones. And if you have an operating system, let's say using Windows, it usually comes with a free firewall program. And then if you connect to your LAN, and your LAN sometimes comes with free firewall software too. So really anything going through it has to go through both firewalls. So we could have layers of firewall. Okay, so firewalls read IP packets, and that's how they decide what messages to go through or not. So the network layer data such as the IP address and port numbers of messages from both the source and destination are read and checked against tables internal to the firewall. Host-based firewalls are usually checking information at the application layer, the OSI or TCP model. And network-based ones are usually checking, they're usually packet filters. So they're reading the packets, usually the network layer. So if you install, like I say, now most of the firewalls are software-based ones. So if you download you can get a free firewall, download it for free, and then there's ones you pay for, usually about $50, $60. So you could set up your policies, sometimes what they refer to as an allow policy or a deny policy. And you could say all packets that do not meet the allow criteria get blocked. That's kind of an allow policy. And you can have a deny policy. All packets that meet the deny criteria are blocked. So for example, you bring up your panel, this is just a little snippet, a picture of the firewall. We could say I'm going to add a bunch of policies. And I could say I want to deny any access coming from this destination, and I can type in the IP address directly. So if a message is coming from this IP address and any port, I'm going to deny access to it. So if this was my only rule, pretend there was no more rules, we could just keep adding rules as time goes on. But if this was my only rule, then basically any message coming into my computer, the message comes in, I'm going to read the TCP header, and if the destination is coming from this IP address, doesn't matter what the port is, I'm going to block it, because I set it up as a block. If I want to block other things, I could also say deny any of TCP messages that come in from any IP address if it's coming in on this port. So maybe I'm trying to shut down all communications from anywhere in the world coming into this port. So really what I'm doing is shutting down that port on my machine. Then I could throw in another rule, allow any local area network traffic. And then so then it gets into the thing where if you used a deny to block something and you used allow and it got through, which one trumps which one, that's kind of an interesting story. But usually the allow ones would trump the deny ones. But you want to try to not have conflicting rules. So this would be allow any of the local area network, any of the wireless communication to come through. Okay, and you could just keep adding, like, you could there's a link to add more rules. You could just keep adding rules describing what can and cannot go into your firewall. Okay, so have you ever gotten a message like this? This message comes up. So this is most likely, it's very likely your operating system came with a free firewall. And okay. So let's say you're running some program and it makes a call to a piece of software that's not on your machine. Your operating system would say, oh, I know where to get this piece of software, let me go after Oracle. And they have a copy of the software, I need to copy it onto your machine. But your firewall is saying, I'm not letting anything in from Oracle. Maybe it's set up some default way. And so when the message came into your computer, it saw where it was coming from. Now we could, this is interesting, we could put in our firewall rules, we could put IP addresses. Or you could say www.oracle.com, and then anything coming from Oracle would, well, that gets a little tricky. So, well, yeah, I kind of get to that a little bit later. So But anyway, let's say a message came in from an IP address that our firewall finds it skeptical. So instead of just saying, no, you can't come in, and you sit there and your program can't run, a message could pop up saying, this one was in our list of programs to not let through, however, we'll give you a chance to override it. If you would like this to come through, we can have it come through. So it's basically asking you, the firewall caught this, the message is trying to come in, and actually if the firewall is running on your machine, the message is already inside your machine, but it hasn't gotten into where it could cause damage. And then if you hit run, it'll allow it to run. If you say cancel, that means you won't let the message through. Okay. So, yeah, so this is the idea about names versus IP addresses. So there's a thing called the domain name system, the DSN, and this is basically a map of names. So it'd be, you know, you can think of it as a big two-column table, a map of names and IP addresses. But you know, sometimes Facebook has many IP addresses, right? If everyone went to the same server, they would be overloaded. So they have many copies of your, so the name, the URL, www.facebook.com, can get routed to many, many different servers at different IP addresses. So if in your firewall, you were to say, I would like to block www.facebook.com, what will happen is your computer will run out and ask the internet what is the IP address of that, and one of the many IP addresses will come back, and now you'll be blocking this IP address. If somebody then sent a message directly to a different server, also serving Facebook, that would not get blocked. So it's usually better to find all the IP addresses of Facebook and then block all of those. Don't just block Facebook.com. So yeah, one little side note about DSNs and using that. I mean, it works fine if it's a website that only has one IP address. Then you can block it by the URL or the IP address, either way. Okay. Okay. Then there are other, electronic devices that are part of a network you can use to put a network together. So we have the idea of a router. It's kind of a hierarchy, a router, and then we could have switches, switch 1 and switch 2, and then a switch could have hubs plug into them, and then computers can plug into a hub. And if you ran out of room on one of your hubs, you could have a bridge. You could connect one computer to another computer, and they can string together and connect into a switch. So as messages are coming in from the internet, they're coming in through here and then working their way through a switch and then into a hub and then into a PC and over a bridge. And you might say, where would we put our firewall in this case? But anyway, so a hub connects a few computers together. All messages sent out of one computer are broadcast or spanned to all the other computers on that hub. And so here's kind of one thing. So suppose these two computers are connected to the same hub, and I want to send a message from this computer to this computer. We could save time if I don't send it out through the internet, have the internet look up where the IP address is, and then send it back to here. I could just send it directly there. That would save a lot of time. So if you're connected on a hub, any message sent from one computer gets sent to all of them. If it wasn't meant for you, then you would ignore it. Kind of like the token ring concept we talked about earlier in the course. A switch can be used to join switched LANs. So we could have multiple LANs plugged into this switch, and then we could route messages from one LAN to another. A router connects at least two networks together. So if this was a network, this piece was a network, and this was a network, then a router can connect those together. So the reason for this hierarchy is just to get messages that are internal, maybe internal to this hub, to get message passing faster. And then maybe inside our network we could get messages faster. And try not to go out to the internet if we can. And then, so remember our stack from the OSI model. So hubs basically work at the physical level, the electronic disk being said. Switches usually look at information in the data link level and make decisions who to send a message to. And routers are network, kind of network and transport, looking at that information. Okay, so then, all right, so now, so we talked about how we can protect some of our computer systems by putting up a firewall in front of them. So it's like all the people in our company are all on one side of the firewall, and we protect all the people in our company, all the computers in our company. But what if the people in our company who we wanted to keep into our private network, our LAN, our local area network, what if they weren't local? What if they were spread all around the world, but we still wanted to have the feel of a local area network? So what we could do is we can create what they call a virtual private network. So we can have data, we can have, so let's say this was, where is our VPN? It must be this one, because this is where it was connected to. So what we can do is we can set up a virtual private network, and we could have direct connections from this machine. Okay, so here's the thing. This machine is going to get us a collection of IP addresses that are connected to the internet. We connect these IP addresses directly to these IP addresses in a direct encrypted message, so that passing back and forth, nobody can see the message, so it is a private connection. And then we have a router. This is the symbol for a router for this local office. So this is like a LAN for this office. This is a LAN for this office, served by this router. And then these are two kind of just random computers also connected to this VPN. So when you send a message, you're connecting directly to your IP address for this machine, is having a direct conversation to this virtual private network. Any message coming into this virtual private network that then gets sent somewhere else is not going to be sent over the internet. Normally, the normal way, we're not going to send it directly over the internet. We're going to send the message to here. So this server, this VPN is a server, basically. It is taking messages from this IP addresses and reading them here, then using a different IP address, one that is tied to this machine, to send a message. Let's say we wanted to send a message to here. So from the point of view of this regional office, the person sending this message, this person is not going to see this IP address. They're going to get translated at the VPN. So as far as this person is concerned, this person is located in this office. And so this opens up a security problem, having VPNs around. Suppose we had this VPN is in Europe, and this is someone in the USA, and this is someone in Asia. They could send the message to Europe, pick up a European IP address, send the message to, say that was US. So this person thinks the message is coming from this European machine when it's actually coming from here. Now, what's popular, VPNs, you can buy VPNs, you can rent space on a VPN. There could be a company that runs a VPN and you rent so many IP addresses from them. They could keep a log of every message you're sending and then the IP address it got translated into, so if later on there was an investigation, some crime, the government could get involved and say, could you give me a list of the IP addresses that were sending messages in and what corresponding IP addresses they were sending in. So it started off as a very good idea that you can have the people at your company scattered throughout the world or scattered throughout the country, and they could all communicate to each other on a secure network, not sending data through the internet. But then it turns into this idea where it's difficult to track IP addresses. Okay. So let's see, what's interesting here. So here's some textbook definitions. Virtual private network extends private network across a public network. and enables users to send and receive data across shared and public networks as if the devices were directly connected to the private network. VPNs allow employees to securely access corporate intranet, so that's not an internet, it's an internal network, while located outside the office. Okay, so let's see, VPN is created by establishing a virtual point-to-point connection through which a dedicated connection. Right, so basically, it's not like communicating through the internet. These connections can only be understood by this machine and this machine. So there's heavy encryption too. We talked about encryption earlier in the course, but we could have encryption where the decrypting algorithm runs very quickly because it's not a strong encryption. Then we can have very strong encryption. And if we're sending something big like a movie, we're going to spend a lot of time decrypting messages. So using a VPN does slow down your communication. Instead of sending a message directly through the internet from this laptop to this machine, we encrypt it, send it to the VPN, where the message would get decrypted. An IP address translation would be done, the message would get re-encrypted again and then sent to this IP address. And then it would get decrypted over here. So it slows things down, especially if these were spread out, if this was Asia and Europe and the US. Instead of sending the message from one continent to another, it's traveling through two continents, so it could slow the network speed down. Okay. So some of the pros and cons of VPNs are, the obvious pro is VPNs can bypass firewalls. So, let me set that back up. Let me go back here. Suppose you had a firewall in front of this laptop that says you're not allowed to send a message to this regional office. But if you can connect to this VPN, so this VPN has an IP address, the one that you communicate to it with, then it also has a whole collection of IP addresses that it could send messages out saying I'm from that IP address. So you're blocked from communicating from here to here, but you can communicate to here because your firewall didn't block this device. It didn't block this VPN. So any message you can send to here, the VPN software can then translate it to another IP address, and that's not blocked at all. So from a blocking point of view, is there something you could suggest that would have this laptop, if this laptop, the firewall on this laptop wants to block communication to this regional office, maybe this is one IP address. We block the communication to that IP address, but this person could get around it by going to this VPN. And this VPN, so let's say this is Facebook, and the firewall here blocks Facebook. But if we can get a message to this VPN, and this VPN, we tell in our message, which is an encrypted message, we say it's going to Facebook on a certain port. We encrypt that message, send it here. They decrypt it. Oh, this is going to Facebook. I'll send it. Facebook replies, because I'm using this IP address to reply to. Facebook replies. Our table translates, oh, that came in for this guy. I'm going to send the message back to here. This firewall thinks it's getting a message from this VPN. So is there a way in our firewall here to not only block communication to Facebook, but block the communication to this VPN? Anything you... Well, all right, so one thing we don't even know what this is. This is just some VPN company. We don't know what it is. We could maybe start noticing a lot of traffic's going through it. We could also have a policy, because traffic that goes into a VPN is kind of distinctive, we could say, well, this looks like a VPN, and we could block all communication to VPN. But then that's very limiting. But a lot of countries do that. A lot of countries have policies that you're not allowed to communicate to a VPN, because then from the VPN you could communicate to anywhere in the world. So, yeah, so that's an obvious pro to using a VPN. Plus also the people in your at your company can communicate with each other directly and securely, and they don't have to be in the same office. The cons are basically speed and cost. Right? So the speed would be, you know, there's a new link of communication. It goes from you to the VPN and then to your final destination. And both hops have that encryption and decryption algorithms have to run. And you could, if you go to a public VPN server, you sign up to a public VPN server, all your messages are going into the server and you might be competing with other users of that VPN. If you, so, and that's a lot of times you could get free ones that do that, but then there's a lot of competition when you're sending messages. And you could also get a higher end one. They're usually about now, they're about $60 a year to rent a VPN. Yeah, so that's all. That's the talk I just had about firewalls. Firewalls, and then VPNs are the most popular way to get around firewalls. And is that any questions? Okay.